的话题
of electric aviation around the world. Today we go more to the roots, to the first aircraft which will be flying electric, which are flying electric already. And so before I start, let me give you some advice for the housekeeping. The setup of eFlight Forum, as it's online due to Corona this year only, is that we have the Zoom stream, and it's also live streamed on YouTube, and it's available. So it's basically available around the world, and we'll also have guests around the world. So if you have friends who still want to join, they also can join. We have a large capacity for people joining. And on the other hand, it's also, if you want to participate and if you want to ask questions, you should join the Zoom session. In each session, we have several speakers. Everybody presents. Then after the presentation, we come back to a panel where we have a Q&A sessions. If you want to ask questions, please do so in the chat. There will be people in the chat marked with Q&A, where you can send the questions to, and then we will read it and get the answers. And then after this session, we'll try to do a real kind of meeting, like in a real meeting, as we can't see us in reality. We'll have breakout rooms. Having this said, I think we get started. Our day is under the banner Commercialization of Electric Airplanes. And our first session is small electric airplanes, which logical-wise are the most common ones coming to the market. So our first speaker is also the company who is the first company who did bring an electric aircraft to the market. They were on the market with the Taurus electric motor glider. They now have the Electro Alpha and the Velis on there. So yesterday we had the technical director of Pipiestrel talking about their electric propulsion system. Today I'm very honored to have Danny Wu, CEO of Pipiestrel China. And Danny, yeah, please give us an update what's happening with Pipiestrel in China and in general with the system. Will you share the screen or shall we play the presentation? You're muted still. I think you're muted. Can you unmute? Danny is still muted. It should be.
Hello.
Now we hear you. Okay.
Hello.
Sorry for that. So yeah, do you want to share your screen? Okay, see it. Perfect. Okay, screen is yours. I mute myself.
Thank you. Thank you, first of all, for having me. It's been a long time since we spoke last year in China, and I'm looking forward to sharing some of the concept we are doing about Pipiestrel aircraft here in China again. Okay, so please, to the first slide, please. Yes, just a little bit background about Pipiestrel. For those of people who don't know about Pipiestrel, we are an aircraft manufacturing, originally based at headquarters in Slovenia. We are now a global entity that we are expanding to 95 different countries. We are one of the very few aircraft that started off with composite material. So the characteristic of our aircraft is quite unique. With our high gliding ratios and composite material and parachutes, etc. So we do have quite a less drag on the aircraft, and we can perform some of the maneuver which our competitive other aircraft cannot perform. So that's the basic concept of our Pipiestrel philosophy. Next slide, please. Basically, we do the whole range from R&D all the way to the certification and production procedures. We now have an operation base in Slovenia. We have our own R&D center also in Slovenia, and we have a production capacity now in Italy for our four-seater Pantera. And of course, for the past 5 years, we have been expanding to the Asia Pacific market, predominantly for China. And we have also been in the progress of setting up the factory in China, in Nanjing, a local city known as Jurong. So we do most of the customer tailor-made, from the concept to the R&D to the actual molding and testings and all the way to the production stages and finally for the certification. So that's just a basic background of what we do. Next slide, please. In terms of certification, we are very proud of having more than 120 different certifications globally. And Slovenia is the first EU country to actually sign the bilateral agreement with China. We have signed the first bilateral agreement with China dated back in 2008. And with the visit of the current administrator from the CAAC to Slovenia in 2016, we have better enhanced that. We now have a total of 4 different types of aircraft that has obtained the Chinese PTC. So we do have quite a range of different aircraft we can perform and fly legally here in China. Next slide, please. For the year 2020, we have made some tremendous progress in a few of our development and aircrafts. Now, first of all, many of you might have heard of, we now have launched the SW121, which is now a EASA certified aircraft. This aircraft, I won't go to too much of the technical details, as I'm sure Tina from yesterday has probably done so. But some of the main characteristics, it is still a 2-seater aircraft, but it is certified for night vision, VFR approval, and also for intentional spins and glide ratio, etc. As you can see listed in the PPT here. So it is a great performing aircraft, and this aircraft is also certified to conduct PPL trainings as well. So this aircraft, we're also in the process of getting validated here in China as well. Next slide, please. And also the Alpha Electro aircraft, which is one of the aircraft now we are in the progress of setting up the production assembly here in China. This is certainly one of the first electric aircraft that has been in the production procedures. It heavily reduces the cost of production in terms of flight training, maintenance, and usage. And as you can see, the energy cost of flying this aircraft can be reduced as low as 0.9 euros, with the running cost, which is roughly around 17 euros, and the running cost, including the VATs and the maintenance, etc., as low as 33 euros. So this aircraft is definitely the next pioneer in terms of electric aircraft. And we are also in the process of getting this aircraft validated in China with the latest bilateral agreement between China and EASA. So this has been a really breakthrough for us in 2020 as well. Next slide, please. In terms of the electric, this year we have also launched the Velisa electric aircraft, especially with our state-of-the-art Pipiestrel designed electric motor as well. So this has been the first electric motor has been ever certified by EASA, and certainly we see a great potential of this electric motor in the future markets. Next slide, please. Our work continues with the vertical takeoff. We have made some tremendous progress this year with the testing of our vertical takeoff. We are expecting hopefully by end of next year to actually have some real prototype coming up to the markets. This is the concept that you have seen in probably for the previous seminars that we have shown for the Uber project. But in the next slide, you will also see that we have launched our logistic version as well. Please, next slide. This is the Nuva V300, which has been released this year. It is still in testing phases. Tina and Evo, I'm sure they've been doing a lot of promotion about this vertical takeoff for logistic cargos. The technical data of this is great. Some of these technical data, I won't go through too much detail, but we are expecting a lot of good progress with this, especially we are one of the few leaders of these vertical takeoff logistic cargo systems. Next slide, please. And of course, we have many other projects such as the 19-seater. This is one of the projects that we are working on with expectation around launching of 2028. Because of time limit, I won't go into too detail of these projects. We can probably discuss that in private later on. Next slide, please. And this year we have made some tremendous progress with our production center in China. We have been based ourselves for the last 3 years in the city of Jurong, which is right next to the great city of Nanjing. The whole concept involves around two a production facility, an R&D center, and also our private airports with the capacity of operating as a whole from basically tailor-made for individual customers all the way to mass production. Next slide, please. Yep, and as you can see, this year, although for the global pandemic, but we have been moving very fast, and finally we have obtained all the right certificates, the permit to fly in the airspace, and as you can see, our R&D center. I'm very happy to say the structural building has been completed just last month. It's a 4-story high building with a total space of over 12,000 square meters. This will be our office, main office, and the R&D center, which the production center will also soon to follow in the 2021. So hopefully by the end of 2021, we will be in the stage of putting together the electric aircraft, the Alpha Electric in China. So that's basically all the time I have for today, and I'm more than happy to answer some questions. Back to you, Willie.
Thank you, and I'm sure people will have quite some questions afterwards. Hope you can answer most of them. For the moment, I think I just have one question, which is very quick in between, because as I remember well, that the aircraft Pipiestrel wants to produce in China are purely electric one. So you're not producing the old, in brackets, combustion engine aircraft here. You're getting them and you're selling them, but you produce just electric aircraft. Is this correct?
Yes, that is correct. We have 2 models, which is the Alpha Electric 2-seater and also the hybrid engine 4-seater Pantera, which will soon follow after the Alpha Electric. So those 2 aircraft will be futurely produced in China for the Asia Pacific markets.
Okay, so thanks. I don't want to disturb our audience, so we'll have the Q&As afterwards. And now I'll move to the next speakers. So if we could have Guo Yilin from LGAA and Tengluan Sui. It's Guo who is presenting first, and it's about another aircraft which was already certified in China as LSA some time ago with the Chinese CAAC. They now also found a partner in Europe to do certification of this aircraft. Hi, Tengluan. And yeah, I'll leave the stage for you. You explain us the aircraft, what you're doing, and where you are with also certifying this aircraft in Europe now, so that it will be available for training fairly soon. Okay, thank you, and stage is yours, the electronic one.
Okay, thank you for having me. And today we are going to present the development of electric aircraft and the certification of RX-1E-A in Europe. Okay, next page, please. There are 3 parts: introduction, research, and progress of electric planes, certification for European markets in Germany. Okay, the first part is introduction. Liaoning General Aviation Academy was founded in 2011 and dedicated to the research and design of general aviation using green energy. And we already established Liaoning series, such as the UAV 2-seater, and we are developing the 4-seater glider and helicopter as well. Okay, next page. Okay, the second part, research and progress, presents our recent works. Basic information of RX-1E-A are as follows. It is certificated in 2018. It has more than 2,200 hours of flight test. It has increased the range and the endurance. Extra safety is guaranteed by its airframe parachute system. Electric motor power is 50 kilowatt. And the recent progress are as follows. Self-developed controller unit is under flight test. It will get ready for further airworthiness certification. 50 amp-hour lithium battery pack in ending phase of certification to replace the current 40 pack for extra 30 minutes flight time. The certification in Germany is in progress, aiming at entering EU markets. Next page, please. Okay, with environmental friendly characteristics, electric seaplane is particularly suitable for countries with a lot of lakes and rivers, such as China, Nordic countries. We developed the LSA plane based on the RX-1E-A. In this summer and autumn, we did many taking off and landing flight tests. Safe and efficient takeoff landing are basically realized, which is meaningful for further development. Next page, please. Electric four-seater, okay. We think electric four-seater RX-4E will be widely accepted for flight training, flight tourist. It is the first electric aircraft which is designed under CAC Part 23. We start to design it in 2018. Maiden flight was last year. Takeoff weight is 1,200 kilogram. The endurance is 1.5 hour with a range of 300 kilometer. CAC accepted the TC application last year. And talking about the certification basis, according to the experience of electric two-seater, we discuss and cooperate with CAC to compile Chapter H draft, which is the certification basis of electric power unit for Part 23. And we cooperate with CAC to compile special condition draft for RX-4E. We cooperate with Shenyang Aircraft Center to research on EPU certification standard and compile compliance method. Okay. Yes, next page, please. Yeah, this is the electric helicopter. In this summer, we made electric helicopter, and the maiden flight is in this summer. This is the first manned electric helicopter in China. Okay, next page, please. Okay, in recent years, although the energy density of lithium-ion battery has been doubled, but it is still the biggest limitation. From this chart, we can see that the higher power density is in demand to solve the problem. So the hydrogen fuel cell is a good choice. Next page, please. We use the four-seater as a platform to design an electric hydrogen hybrid four-seater. Here is a schematic diagram. You can see that the hydrogen fuel cell system is parallel with lithium battery system, and the VCU is coordinated to the two systems to control the motor. Okay, next page, please. Talking about the cooperation, we already cooperate with a lot of companies, and we are going to cooperate with the other companies who like to develop the e-plane. And next goes to Kasaero to talk about our cooperation between us for the RX-1E-A certification in Germany. Okay, next page.
I think, no, he's unmuted. Thank you.
Thanks to Yilin for his introduction to the development of the electric aircraft. So in this part, I will introduce the certification progress of RX-1E-A in Germany. I think this part is more interesting for our Chinese friends, so I will switch to Chinese. And you might need to change your audio track. Okay. 首先我想先介绍一下我们 Kasaero 公司。
Well, first, Let me talk about our Kasaero company. So our Kasaero company focuses on general aviation and carbon fiber materials. Our engineers are proficient in the entire process of aircraft development and manufacturing certification. And we've achieved the 3 TCs within 4 years. Because of this, we can quickly understand the technical design details of RX-1E-A aircraft and assist our Chinese partners in certification work in Germany. Next slide, please. So the light sport aircraft can be certified in Europe in 2 ways. One is through EASA and the other is through the airworthiness approval agencies of each member states. So in Germany, that is DOLV and DAEC. And the route of certification through EASA, according to the requirement of Part 21, the applicants must design agency approvals, and it is very time-consuming and expensive. And the other way is more time-efficient. It can be individuals or organizations. And for those below the 600 kilograms, in Europe, it is the most popular one within the market. So if we achieve the airworthiness in Germany, we can also be certified in other European countries, which could be a really good starting point for us. Next page. So our airworthiness partner is DLV, that is German Light Sport Aircraft Association. This association, together with DLVC, will together issue a number of aircraft registered each year, which can be achieved using a reference for the sales data. So we have a 3-digit sales of LSA in Germany every year. It is a very open and inclusive organization. The documents approved by CAAC can be directly accepted if they meet the requirement. So we do not need a review process again. So these will actually save a lot of cost for us. Next slide. So the DLV basis is adopted by LTFUL. In the first half this year, regulations were revised to include the additional regulations for electric aircraft. This is the first airworthiness standard in the world that conventionalizes the certification of the aircraft. And the applicants can actually be approved with the airworthiness of electric aircraft without the adoption of special conditions. This is very important. And after we obtain the German certification, it can be validated for airworthiness in many other countries because LTFUL is widely recognized. Now, let me talk about our program and process. So first, we will identify the differences between the CAAC and LTFUL, and we can translate the document and get the TC certification. And for the differences in between those regulations, we will carry out tests again, and we will submit the test results to DULV. And based on the revisions, we will test again and complete the report and submit the translated document to DULV to finish our certification, because for every step of the way, the DOLV staff will take part. So we will avoid some of the mistakes and risks. Okay, last page. Due to the pandemic, the certification progress has slowed down, but we will strive to get the airworthiness certification in the first half of next year so that it can fly over the Germany as soon as possible. So that's all for me. Thank you.
One click too slow. Thank you very much. I think I have already listed several questions, but I will wait. I have to be patient as well. Thank you very much for doing this. It's also because we had this aircraft at the Aero already some years ago, and a lot of people were asking. So hello, Maarten. So our next presenter is already online. Perfect. We should unmute him, and then yep, he's unmuted. So I give you the stage free, and yeah, then let's hear what Diamond, who is also a company which has been with the electric path already in the last decade, flying demoners with electric and even hybrid hydrogen propulsion. So I'm really curious what you're working on. And also it's very interesting because it's again also a presentation which is concerning China and Germany, Europe and Germany. Sorry, it's not, no, not Europe and Germany, Europe and China, because Diamond as an Austrian company from Europe has been built up in the last 20 years to the leading GA manufacturer in Germany. And you're now showing us your electric project. So thanks, and stage is yours.
Why did we start this hybrid project? Well, as everybody knows, general aviation is slowly making a shift towards electrification. And we as Diamond wanted to follow. So with this project, we wanted to show that the integration of a hybrid power plant is able to reduce the fuel consumption, reduce the emissions, and at the same time increase the overall efficiency. And with this aircraft, we really wanted to have a physical proof of concept, a so-called technology demonstrator, but also for the development of a certification basis for future development. But first, why hybrid technology? Why not go full electric in the first place? Well, greener flying has always been a trend in aviation, but as everybody knows, battery technology is still lagging behind. And how much? I always compare it with this example. Take 1 kilogram of Jet A fuel and compare the energy in it with 1 kilogram of lithium ion. And at this moment, there's still a factor of 50 difference. Even if you factor in the relatively poor combustion or poor efficiency of combustion engine, there's still a factor of 20 to overcome. So that's why a hybrid aircraft is an ideal compromise between having the benefits of a long range, a long endurance, while also having the benefits of pure electric flight. We did not do this project alone. We did it with several partners. We at Diamond Aircraft were responsible for whole system integration and making the aircraft airworthy in flight test. The Johannes Kepler University did a lot of aerodynamic simulations, and also the Austrian company Terra Group did some static and dynamic analysis of the powertrain. But most importantly, Siemens, now Rolls-Royce, of course, did the complete electric powertrain design of his aircraft. But where did it start? Well, it started in 2011 already with the first serial hybrid motor glider we developed, the DA36 E-Star. And with this prototype, we demonstrated that the hybrid flight principle. And that means that if you have a relatively small combustion engine of, in this case, 30 kilowatts, we are already able to maintain continuous flight. And therefore, these combustion engines can be much smaller and lighter, and therefore also more efficient. And this led to the kickoff of HEMEP. And HEMEP is basically a modified DA40. It's the exact same fuselage. And what we did for this project, we basically took off the gearbox and propeller and put in a electric generator unit in the front. And for the electric propulsion, we added 2 outriggers, engine pods, distributed propulsion units, both housing a 75 kilowatt engine. So how does this system work, or how does it look like? It's basically a symmetrical system having a left hand and a right hand side with 2 motors connected to 2 batteries which act as an energy buffer. Up front we have the combustion engine which powers the generator. And the advantage of having 2 separate systems is, of course, redundancy. And with this redundancy, we add another level of safety, which allowed us to safely test out this new technology. The aircraft can operate in several operating modes. We can operate in full electric mode. Therefore, the battery provides overpower for propulsion, and the generator unit is actually switched off. With this, we have a 30-minute endurance, and this mode is used, for example, for takeoffs. Therefore, you have no local emissions and also a lower noise footprint. We also have cruise mode, where the generator provides just enough power for flight, and full power mode, where the generator runs at full power and is able to recharge the batteries during flight. So the whole hybrid power plant is housed in the front section of the aircraft. And you might ask, why do we use such infrastructure? Well, that's twofold. First of all, because we're modifying an existing aircraft, we want to leave the rest of the aircraft untouched, and therefore all the modifications were only done on the front of the aircraft. And secondly, the canard wing up front helps outbalance the additional mass of the engines and also increased stability of the aircraft. So then the electric powertrain, and it consists of two separate propulsion systems. The maximum power output of the aircraft is 150 kilowatts on the shaft, each motor being able to provide 75 kilowatts. And the system runs on a 450 volt level, powered by two 24 kilowatt hour batteries. And on this battery alone, we can fly for an endurance of 30 minutes. But with the 110 kilowatt generator, we're able to increase the endurance from this 30 minutes to over 5.5 hours. And that shows a real benefit of these hybrid aircraft. And the generator itself, this converts the rotational energy produced by the combustion engine into electrical energy. And it's attached directly to our AE300 Ostro engine and runs up with efficiencies over 90%. Also within the generator, we have two electrical coil sets, which mean even if it's one physical unit, it's still two separate electrical systems. So it has an electric redundancy. So after all this designing and development, which took over 4 years, we were ready to do the first tests. And this is to determine the functioning of each component. And we tested the cooling systems, the high voltage systems, looked at the readback of critical parameters. But as you might know with any development project, this is also the first time you get feedback back, and you also get a big list of things that do not work yet. So it was a big challenge to get things completed. We also did some high-speed taxi tests to determine the stability of the aircraft and also some full power runs. And then after that was done, we were ready for the first flight, the so-called maiden flight. And we did that on an early morning where cool and calm conditions prevailed. The reason for that is that we did test and calculate the stability of the aircraft, but we were only able to test it up to takeoff speed. And to not take any additional risks, we want the atmosphere to be as stable as possible, so that we are 100% sure that it will function safely. Taxiing to the runway, and this picture I really like because it demonstrates the slender, small size of these electric engine pods, which are much smaller than, for example, a combustion engine. And that also shows the benefit of any electric propulsion unit or distributed propulsion units, just its small size and its flexibility to be placed anywhere on the aircraft. Then just before takeoff, the test pilot does a quick full power run just to test that both systems are stable and the temperatures are stable. And then he was off, and the takeoff was uneventful. And actually within 1 minute, the pilot radioed back on the ground that the controllability and handleability of his aircraft were actually far better than he expected. And also the achieved rate of climb was better than the DA40, which is also due to the increase of power. During this test flight, we tested out the different operating modes. So the full electric flight takeoff we did. Then we did the hybrid flying, where the generator just provides enough power to for sustained flight. And also we did the full power and recharged the batteries. We demonstrated that continuous flight was possible. Even though the first flight only took 20 minutes, the further development flights reached to over an hour. And theoretically, we can run up to 5 hours and 30 minutes with full tanks. And then on approach, this is where the pilot noticed something different. He had trouble actually descending the aircraft. He had a much lower sink rate than expected. And this is due to the low resistance of the windmilling of the propellers. because the electric motors have a much lower resistance. And this shows a future improvement. You can actually use that to brake the propellers and to allow for regeneration of energy. And this test flight ended with a textbook landing and of course a very happy test pilot. So I would like to finish off with just discussing where will the future of Diamond be? So where will it go from here? Well, after the HEMEP test campaign, we realized the true potential of electric flight, and that the hybrid electric powertrain is the way to go if you want to have a similar range as opposed to combustion engined aircraft. However, we did notice in our case that the weight penalty of basically having a double system doesn't allow this architecture to come into its full potential for these small aircraft. The current battery technology allows for small full electric aircraft, and we also expect this first successful application of electric aviation to be in this pilot training market. This is why Diamond at this moment is developing a green pilot training solution, the DA40EP, which is a full electric four-seater for pattern training and near field operation. And it will be equipped with a fast charge battery system, but also an option for swappable battery. Endurance of around 1 hour and 30 minutes, which may not sound much, but that's with the current state-of-the-art batteries, and will be expected to increase in the future, of course. And the philosophy within Diamond is to have an identical cockpit layout between this version, so the electric version, and the classical combustion engine version, which means that during pilot training, you can very easily make the conversion between the two types. Well, and I think the whole aviation industry is excited to see what the future holds, but one thing is for sure, e-aviation will at one moment dominate this industry, and it's up to all of us to make this happen. And on that note, I would like to thank you all.
Thank you very much. Really great thing also to having some really great news, because I think the DA40 full electric was not published much around. So we have some kind of premiere here as well. Maybe you also later in the discussion can disclose some more details on this aircraft, because I think this is, like we said, this is electric coming to the market. And there are some other news which we just received in the world of electric flying, which I just want to let you know when you join here before the next speaker comes on. And this is, we just got the news that, which was rumors before, that Joby just acquired Uber Elevate, the core of, or actually the pushing force of the e-mobility sector. And as we know that in Joby there is a large investment of Toyota, and at the same time today there will be a Hyundai speaking at another event. So we see there is a lot of force coming into electric aviation, and we heard yesterday that with the fuel cell there may be also an even cleaner solution than if we have a hybrid or if we have just battery, because then we have short range. But thank you very much, Maarten. And I would like to ask on stage next speaker, which is Matthias Betsch. I hope he can come on. Yes, here he is, Matthias. And talking about another electric training aircraft. And I know we talked about electric over years. Flight Design has been working on different electric and hybrid solution over years. So Matthias, I'll leave the stage for you, and we talk later in the session. Thank you.
Thank you very much, Willy. And it's a pleasure to be here. I'm very sorry that that's not a personal meeting. But for a video conference, I think it's super organized and was very interesting so far. When we normally look into new airplanes, then we do not look at first in the airplane. We look at first what the customer really wants from that airplane. In our case, we have a new series of airplane. It's the F series, which consists out of 2- and 4-seat airplanes. Which is not specific for a certain kind of propulsion. It's open to combustion engines, to battery-powered electric engines, to hydrogen solutions. So it's an open, it's an open platform. And the main target at the moment for the F2E, the first electrical, I mean, we have the F2, which is already just on the market, and the F2E is flight schools. So when we look, we say, what are the requirements of flight schools? And the requirements, the flight schools are very commercial orientated. They need low hour and service costs. Principally, all flight schools around the world have the same educational process. And they want to have a high efficiency during flight training. Means they want that their students are learning very fast to be safe in the air. And that's the next thing. They have a very, very high priority on safety for flight with and without instructor. Because on the first solo flights, the student should be really confident and safe. Next slide, please. When we look at the flight school has a much higher ecological impact than a private pilot. Because a private pilot flies 50 to 100 hours a year, a flight school 500 to even up to 1,500 hours per year. I had difficulties to believe that, the 1,500 hours, but I've really seen that last year's logbook of flight training academies, that they really log 1,500 hours per year. A higher fuel consumption with that CO emission per airplane, when you use 18 with the Rotax engine to 40 with conventional aircraft engine liter fuel per hour. And additionally, you have a high public visibility because a flight school is known, the aircraft flying a lot, they start a lot, so it's present. That at the end leads that 100 flight school airplanes are the equivalent of 1,000 to 3,000 private used airplanes. And this is really a lot. And with that, when we say as a private pilot, where you fly 50, 100 hours a year, the reduction of the CO2 emission is not a real big thing. But when a flight school with a high usage of the airplane reduce the CO2 emission, that has really a certain impact. Next slide, please. Hello? Can I get the next slide, please? Thank you. Profitability. Minimum practical flight training requirements for a professional flight schools are economic cruise in electric training airplane, something like 60 to 70 knots. Economic cruise in a piston training airplane, maybe 90 to 110 knots. And minimum 30 mid reserve is required. So to comply with the low energy density of the batteries today, compared with the fuel, the best is reducing the energy consumption. And this you can do when you reduce the economic cruise. But reduced economic cruise is also extending your flight time in cross-country flights. And in cross-country flights, you have a requirement for a minimum distances. So with that, you come very soon to a point where you cannot fly the distance inside your time frame you can fly with the airplane. Next slide, please. The flight orders you are giving is average length of a circuit flight is approximately 15 to 20 nautical miles with a maximum of 7 circuits per hour. With that, you have a flight time of 2 hours 15 to 2 hours 50, including 30 minutes of reserve. When you have the same with, instead of 60 knots cruise speed, you have it with 70 knots of cruise speed, you reduce your flight time from 1 hour 54 to 2 hours 22, including 30 minutes of reserve. The cross-country flight distance, according to minimum requirements, is for LPL is 150 nautical miles. When you do when you do a PPLA, not a LAPL, when you do a PPLA, and then you need to have when you do this with a 60 knots of cruise speed, then you have 3 hours of flight time with 30 minutes reserve, or when you do it with 70 knots, you have a 2 hours 30 minutes of flight time. A typical cross-country flight time during flight training is 1 hour 30 plus 30 minutes reserve, so it's 30 hours. Average block time in normal flight training is 45 minutes to 1 hour. So, and when we overlook that, we know that real flight training is possible when you have a 2 hours flight time plus 30 minutes of reserve. Everything below that will limit the flight schools on certain areas where they can use electric airplane, but they cannot use it for the full training. And important for, when we say important for the flight school is the safety, for them it's really important to have that 30 minutes of reserve. And 30 minutes of reserve is really the minimum, because I think no flight school will send up their airplane with 7 liters of fuel in the tank. Next slide, please. So we think that the economic cruise for electric airplane should be 75 knots. And then you should have a range of 2 hours plus 30 minutes reserve. With that, you need a battery capacity of 75 kilowatts at 30 kilowatt hours for economic cruise. Yeah? And the 75 kilowatt battery weighs today around 375 kilograms, with 200 kilograms of pilot and instructor, and a 300 kilogram airplane weight. You end up in total estimate weight of roughly about 875 kilograms. What we have done with the F2A, where we started with the Siemens originally, which is now Rolls-Royce, and working together with Liaoning in China for the battery system. The F2E is structurally an F4, a 4-seat airplane, with the outside dimensions of a 2-seat airplane of the F2. And with this combination, we have pretty low structural weight with enough capacity for a battery, and the capacity of the F2E will increase with the development of batteries or with the development of hydrogen solutions. Next slide, please. The inside of the F2E is the same than the inside of an F2. You see there these vertical 2 black stripes. That's the pedal-mounted airbags, which is first time in a serial airplane. It's a Garmin avionics suite. You see the throttle in the middle. You see the rescue handle on the side. So it's a conventional airplane with the same layout for all the F series, so that if you have sitting in one F series airplane, then you sit in the next one, you can fly it immediately. The prototype of this airplane is flying since beginning of 2019. We plan to have a compliant prototype flying by end of 21, so that you have a CS23 certified electric airplane in 2022. Next slide, please. So, flight training with electric aircraft is coming very close. It's not anymore fantasy. So have a look, if you like, at the F2, which is Rolls-Royce powered with the Lithium batteries. Thank you very much. And thanks for your attention.
Audio. Sorry for this. We had a little problem unmuting myself. Thank you very much, Matthias, and looking very good for having electric aircraft soon. I remember flying my very first electric aircraft in 2009, and I was very, very impressed. And this was a time when I started to have with the electric aircraft flying myself in 2009, having the idea that this could really be something great. We started the eFlight Expo at Aero at the very first time with very little tube and fabric aircraft with a little electric motors on it, single seaters. And if we see where we are going now, which is about a decade, I think it's a huge change. So I would ask back on stage, so please switch on that we have all the speakers of this session on the screen. So if you switch on your camera, then I should see you all on the screen together with you. So Matthias, Maarten, Guo and Tengluan. So yep, 1, 2, 3, 4. Now only Matthias is missing. Matthias, you come and please unmute yourself. It should be possible to unmute, because we have to explain that we, as we have a lot of people in the session, between over 200, sometimes 150, it's going up and down. That's why we mute yourself normally and only unmute when you are on the stage to speak or when you should ask a question. Matthias, when you hear me, I hope you're not just rushed out of the session.
No, now I hear you.
but your camera is off. Perhaps
okay, then I can also switch on my
otherwise
camera.
You're not on the, yeah, now it looks much better. Just for information, like also the audience, if you have friends who also want to join in, you also can go to YouTube. It's live streamed on YouTube under just Flying Willy, like my name and Flying Before. So people can find it there. So coming to my first question, Danny, you already have electric aircraft on the market. When will or if the Electro Alpha already certified in China? And we heard yesterday from Tina that there is this Velis, which is a similar aircraft, but there are differences. When will this aircraft certified in China, and when do you think you will have the first manufactured in China Pipiestrel flying in China?
Well, as you know, in terms of technical questions, the electric Alpha is actually not governed under the Slovenian CAC. It's actually partly, mostly EASA. So one of the reasons that we have been waiting for is the bilateral agreement between CAAC and EASA. So that particular aircraft, I think we will be starting the formal procedure of getting the validation process we actually in the process of doing that right now. So we're taking full advantage of that situation. I think with the factory ready to be complete by the end of next year, we will be in parallel in comparison to bringing in the molds and training of the workers, getting all the equipments in place as well. So as early as end of next year, we should be able to get some actual aircraft made in China. And of course, with the flying under the experimental, it is also possible to fly as well.
So just now for the Electro Alpha, just for understanding, the Electro Alpha, it's flying under the Slovenian CAA and you work on a validation there. And with the Velis, you would see like we had the CAAC deputy director of the certification department, and she said they are working on validations in this field as well. So there you would look to have a validation of the CSLSA certificate.
That's correct.
Any idea when you think you can expect this?
Well, like I said, the bilateral agreement has only been negotiated successfully this year. And
yes.
We don't know how long it will take in terms of getting everything validated. And I'm sure that there's more than technical issues arise with that bilateral agreement. There's also political reasons as well. So that we don't, at this stage, I cannot give you a definite answer. All we can say is we are working as fast as we can in terms of the technical side.
Okay, and so I pass this question also to your colleagues, because I think, Maarten, I think your aircraft and Matthias, you both will fly under Part 23, as I understand, or will
Correct, yeah.
will one of your aircraft fly as CSLSA?
No, for the Diamond aircraft DA-40EP.
Yeah, no, it's a 4-seat. Yeah, it's a okay. So and Matthias, you mentioned
and the same. I mean, by White, it's from the beginning. I mean, we think that the CS23 certificate for the F2, I mean, the combustion engine version, that we will get in spring 2021. And as soon as we have that, then I mean, also the F2E is flying at the moment on the permit to fly, EASA permit to fly. It's not flown as an ultralight, yeah. And then we'll continue, and it will be both will be CS23 aircraft that you really can use them worldwide without any limitations.
And you have any idea, like again, for both you the question, you have any idea or what you think when CAC acceptance of this or validation could be in place? You had any talks already?
I think it's looking, no, we didn't talk really over that, but it looks pretty good, because you can find even in the internet at the moment already on the CAAC webpage and on the EASA webpage, you can find even application forms for validation. That means you understand? I mean, all the bureaucratic things normally after the signature, they seem to be already done.
Yeah, paper works faster than it flies faster than the aircraft. So paper planes.
Yes. So I think that the CAC did really a fantastic job there. When I heard that yesterday, I was really very, very positively surprised. And also with this Part H and so on. I mean, I'm not through everything at the moment, but it looks very, very good. It looks much better than I expected. Yeah.
Okay, Maarten, what do you think?
Well, I actually agree with Matthias on that. Really, as you see, more and more companies are proposing their own electric flying solution, and at a certain moment, they have like no other choice than to accept it as well. Yes, we've also seen these application forms already being available, and I think certifying it on the CS23 EASA wide, it's a very big body, and it has a much higher chance of the CAAC of accepting the standards, the certified aircraft as is, and then if you were to develop it under a much smaller body. So we're also at Diamond Aircraft very positive, that we would have shared the aircraft across 3 different states.
Okay, concerning this, I I would have the question because like Kasaero and you're certifying the RX-1E. I think it's a second model which you're working on. It's not the first one which was certified. Certifying this under DULV as an ultralight. Is this correct?
Yes, as I know, this is the first pure electric aircraft we certified. Before we have done something with sail airplane, but this one is a pure electric aircraft. Yeah, this is the first one, the pure electric aircraft. Yeah.
Okay, and having this said, so you work with DULV to certify this aircraft in the ultralight category. So I suppose it's you will use the full weight up to 600 kilograms, correct?
Yes, we have kept it. Yes. Right.
Have you had, as you mentioned before, there should be or an acceptance in other European countries, but there are other countries like France which have a different weight limit, even which is 525 only. But I heard sometimes, as we also have a French magazine, and there we have a good connection, that also the GGAC there thinks of giving some special allowance for electric aircraft. Do you have any information on this?
Right now, we don't have any more information about that, but we are working on the battery design. We can make some battery, we can remove some battery, and Yilin may explain something. So if we want to certify our aircraft in France, we can remove more battery, and then we can certify it. And yeah, others can be the payload.
I know you can certify, but if you certify, then where will you, and perhaps also this is a question to Guo, where will you land with your flight time then? Because even with 600 kilogram, I think probably flight time is limited. If you take more batteries out, there is not so much time to fly left, which is a basic problem of the energy density of batteries.
Yeah, right now that is a big problem right now. So we are focused on the German certification. After that, when we go to the France, let's discuss about these details. And maybe that time France will change their regulation and like other European countries to the 600 kilogram.
Okay. Okay. But what is the flight time? Just last question then, because then we, what is what is the question, or what is the flight time you want to achieve with the aircraft, or you can achieve with the aircraft you have now, probably also Guo? What's the maximum flight time of the up-to-date model of the RX two-seater?
Yeah, I think this question, Yilin is the best person to answer this question. Yeah.
Yeah.
Yes, 2 hours.
2 hours. So yes. 2 hours. Okay. And this is including a reserve or not including a reserve?
Including the reserve, because according to the GAC, okay.
So good. Then I think yesterday we heard a lot about fuel cell hydrogen. Danny, I know that Ivo, the founder and big boss at Pipiestrel, he told me about his hydrogen plans already some time ago, and also even for larger plane, for a 19-seater. Do you know if there is also any progress in the small sector of Pipiestrel looking into fuel cell and hydrogen, or if it's still meant to be pure electric?
Well, as you know, our aircraft for the second phase of our Chinese project, the Pantera, which will be scheduled to be manufactured in China, that is also the hydrogen version as well. Okay. So I think the technology so far with Pipiestrel, we have done a lot of research and R&D for a number of years in terms of the hydrogen fuel cell, and I think it's right now at the right time it would certainly come before the 19-seater.
Okay, definitely.
So for our
okay,
plans in
good.
China, within 5 years, we should able to massively produce a hydrogen fuel cell 4-seater Pantera in China. That is our objective.
Okay, and how is this there? Have you talked already with the authorities there of, and this is a question I think for everybody, because everybody talked at some point for fuel cell and hydrogen about certification of such a hydrogen propulsion system.
You mean with CAC?
Yes.
Yes, of course. We have a number of different discussions, and we have also informed them about our plans on that. The CAC, as you know, is very progressive, and they're very supportive in terms of renewable energy. So we are getting a various of different support from CAC from all different levels, whether that's from the central headquarters all the way down to the East China region office as well. Although there is no clear definition at this stage, but I think it's one of the questions that what comes first, chicken or the egg, because you cannot expect the regulators to come up with the answers and the clauses of the term agreement just by themselves. So you're certainly going to need some examples as well. So I think it's a matter of making sure that our products and we keep informed with the CAC about research and development and try to come up with a solution together. But from overall speaking, we do have a very positive response from CAC.
Yilin, perhaps I think you're muted. If you unmute and then could answer, because you're doing research with hydrogen already in your company quite several years already as well. What is your impression like when such system may be certified and maybe that you really can use it? Just a time frame estimation. Hello? Hello, Yilin, do you hear me?
Oh yeah, hello.
Okay.
Yeah, hello. Okay. I think in just right now, I just mentioned that in 5 years, yeah, because it will, I won't expect that process will be very fluid.
Yes. Okay. Matthias,
yeah.
you have any thoughts?
Yes. Regarding hydrogen, I mean, at the end, when you say what is the authorities are doing, I mean, it's very simple. As a company, you should start with a system safety analysis, and then you go with a system safety analysis. When you have your system architecture structured, you go to the authorities and you suggest what you want to do. Yeah, and if you do that right, then I think because principally for all that questions are regulations there. So it's not that you have to reinvent regulations. You have to only follow the path. And I mean, we are also actively in one hydrogen project at the moment. And it's for me, there's two passes. I mean, I think, like was also mentioned yesterday, that solid state batteries are the future when you go to safety. The problem is that you have a high power density, but not a high energy. That means when you need a lot of power for takeoff, you have a problem to do this with that generation of solid state batteries, which is coming at the moment. But you can solve with that the safety problem. So now, what do you do to combine that to make a thing going, where you have on one side the safety and the high power density of a solid state battery, but you also have the high energy output you need for the start phase and so on. Yeah. So if this can be solved and it goes really fast with the energy density on a solid state battery, then the solid state battery is a real good source of energy. On the hydrogen at the moment, I mean, the limit is just by the pressure by the tanks. So you need, I mean, if you go from really efficiency, also from fuel cells and so on, roughly you need a quarter of the weight of fuel to compensate it with hydrogen. So 100 kilos of fuel, you need 25 kilos of hydrogen, and then you fly the same distance. Now, that means when you have 25 kilos of hydrogen and you have 75 kilos of tank weight, then you are really competitive to normal fuel, and then hydrogen is the way. But at the moment, when you look, you have let's say 8 kilos of hydrogen, and you have a ratio of maybe 5, 6, 7, 8, with some problems also safety-wise, in crash cases or system safety analysis. So that's the two ways to go. I think authorities are open. If somebody provides a visible, good solution, I think the certification is not such a big issue.
Okay, Maarten, you mentioned in your presentation that you're also working on in the long term on a fuel cell version of the aircraft due to the range. Where do you think, where are you with the development right now? As Diamond now is a Chinese company as well, or Chinese owned company as well, are there any cooperations? As I know, the Chinese government is quite supportive as the EU Commission for fuel cell and hydrogen technology. So can you give a quick view into Diamond's view of this? Your mic is muted. Can you unmute, Xin? Can you? Okay.
Yes, I saw you, but I was able to unmute myself. Yes, Diamond has been also looking into alternative fuels over the last 20 years already. I think it was in 2001 where we collaborated with Boeing for our first fuel cell aircraft motor glider. We see that either hybrid aircraft, so with a fossil fuel as energy source, and in a more future hybrid solutions. And for these smaller, say, pilot training aircraft, private aircraft, single engine aircraft, we see the development into a pure 100% electric battery powered. However, once you go a step further to, say, the smaller commuter aircraft, this is where a hydrogen solution will be necessary in order to go towards this electrification step. Our plan is also what we're developing with this HEMEP platform is it's looking into different power sources. We've already investigated the hybrid power, so diesel combustion engine with a generator. Future step for us is also to look into the fuel cell technology. First, of course, with compressed hydrogen, but the future will also be having liquid hydrogen or cryogenic hydrogen, because that allows a much lower tank weights. But there's much more development is needed in order for that to function. There's a whole lot of problems which will happen once you go into that field. But no, we're positive. It's just like with the electric aircraft, it took some time for it to get mature enough. At this moment, it's mature enough for what you see, say, the pilot training market, small aircraft. And that's at the same step where we are right now with, say, fuel cell hydrogen power. It's right now at the development stage, but we expect within, say, the next 5 years, it will become a mature enough level that you can see actual applications in serial projects. So that's a bit our vision on it.
Okay, so thank you very much for the presentations. Now we have already several requests from people who want to ask their questions themselves in the breakout rooms. So I just give a little explanation how it works, because as soon as we switch on the breakout rooms, you will not have anymore the option of translation. Because the translation and breakout room doesn't work together. You have at the bottom of your screen an option where you can go to and select the room. Sometimes it depends on the browser you have first on top all the people which are not already gone to a room, and at the bottom you have the list of the rooms. But it gives, when you have a smaller screen, you have the functionality at the bottom of the screen, and then you have right of it 3 points. If you click on the points, then there opens more options, and at the bottom normally there is breakout session. If you click on this, then it will open the breakout session, and you can select the room. And we will have one room for each speaker, and then you can go into the rooms and speak with a person. At this point, you then should switch on your mic, switch on your camera, so the people can see you and you can ask your questions. And you still can always, over the chat, you can either chat to everybody, which some people have done, but you also can select and then chat to the speaker directly, and then say, okay, I'll send you my credentials. We're also going to save all the chats, so nothing gets lost. And if somebody asks for his credential getting moved to one of the speakers, we'll make sure that this happens after the event. But if you do it right now and you post your phone number, your WeChat, WhatsApp, whatsoever, then the speaker will have it and can stay in contact to you later. It worked quite well yesterday. Could work better because it's quite new function. That's why you always have to install the latest version of Zoom for having this functionality. Otherwise, you can ask in the chat to be moved into a room, but that's a little bit difficult as we have 130 people, up to 200 people in the chat to move everybody. So now we're gonna start. Xin? No? You have to reset the break. 1 second, we just have to reset the breakout room for having the right name so that the people also find you. So for this point, perhaps I go back to one question, and then as soon as the breakout rooms are ready, we'll start the session. Question to all of you, quick answer. Do you also have larger planes in planning? Some of you mentioned briefly, but larger planes in planning, because most of your company either have plans or already have larger planes, which could fly electric or hybrid. Perhaps start with Danny first.
Yes, of course. We have the 19-seaters, and we also have the 4-seater, which will be hopefully to be successfully manufactured in China. Yes. And you know, with Ivo Bascaro, it's really what his dreams and ambition. And I'm sure that we'll go beyond that in the near future as well.
Okay, Maarten?
Yes, we have, of course, already a large portfolio of aircraft, of single and multi-engine aircraft. And of course, for all these aircraft, we're looking into the possibility of electrifying them. In the past, we've also looked into options of going for a small commuter class aircraft, so up to 19 seats. We've had some projects running in the past, and every time we see a leap in battery technology or a leap in engine technology, we look back at that and see if it might be an application possible.
Okay, Guo Yilin, sorry, your mic is muted again. Can you unmute Yilin?
Oh, okay. Yeah, we have our plan for larger aircraft using green energy. Right now we have 11-seater, and also we have 19-seater in our progress.
So quick answer, Matthias, because the rooms are ready, and then we go to the breakout.
Very quick answer, yes.
Yes. Okay, so let's go to the breakout. We start the breakouts right now, and after the breakout session, you will be automatically removed and muted to the main session, and we continue with the next session, which is exactly about this subject, small commuter aircraft. That's why I ask it. And so talk to you soon. How can you get eFlight Journal? Just scan the QR code on this page. Or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying eVTOLs and everything which is connected with electric mobility in the air. Or you can click the link on the top and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching and goodbye.